So, very good afternoon, my dear participants, for this special course on climate smart agriculture. Today's our topic of discussion is geospatial inputs for agriculture drought monitoring and vulnerability assessment. So, during this particular lecture, we will cover about drought, the fundamental, the background, its definition, the related to agriculture aspects, the impact and causes, then various types of drought and their categorization, and what are the conventional approach to assess the meteorological drought or agricultural drought, and how remote sensing can be precisely used for assessment and monitoring of drought. And then we will discuss about the NADAMS project, which is National Agriculture Drought Assessment and Monitoring System, which is now taken care by MNCFC, which is Mahana Lobby's National Crop Forecasting Center, Government of India. Then its methodology part, like how they use various kind of indices, ground information, remote sensing, geospatial technology for assessment of drought in terms of monitoring and assessment part. Then few case studies, which will give you a better idea and enlighten the about information how we can use geospatial technology for assessment and monitoring of agricultural drought. Then we will discuss about the various global and regional products. So this is all content about our today's lecture. So before starting this lecture, we have to know about what are the drought, and before the definition and its detail, we have to discuss the part of background. So with this specific reference, I categorize here 4 points, specific as mentioned: damage, economy, onset and prediction, and aggregate in India. So if I'm talking about various kind of natural disaster, like if I'm talking about earthquake, very specifically categorize the natural disaster like landslide, flood, drought, cyclone, then volcano eruptions. So among all kind of natural disaster, the drought is one of kind of disaster which is most damaging among all in terms of the monetary loss as well as the price loss. So if I'm saying related to economy parts, so at a global scale, there is around $6 to $8 billion economic loss in each year because of the drought related disaster in various parts of globe, including India. Then the third point as specific onset and prediction, which is much more complex and difficult to define, like is the condition is onset of drought, and same time like in a particular season, specifically in kharif season or monsoon period, to define the prediction of drought in any local to regional scale. So if I'm saying very first about onset of drought, so onset we cannot say like for a period of 1 day or couple of days dry spell and we can say it's a drought in a region specific. So we have to categorize the specific drought part in a significant period of abnormal dry weather condition, which is specifically abnormality or you can say unavailability of rainfall in the particular region. And same time, if I'm talking the prediction part, which is much more complex, as per you already have a quality idea about India geography. Like we have already surrounded three side of ocean, and same time our interaction of global wind circulations on mainland area as well as the ocean area, which make the system more complex in terms of prediction part. So prediction of rainfall availability in various parts of country, and same time because of unavailability of rainfall is the condition may prolong and define the drought condition, which is also a point of research as well as the understanding. And when we're talking about India, which is mainly where all our population mainly dependent on agriculture, that's why it's called as agrarian India or agricultural land. So the incidence of drought, which is you can say the recurring phenomena in India in various parts of country, like if I'm defined a region specific, area specific, like parts of Rajasthan, Gujarat, Uttar Pradesh, specifically Bundelkhand region, Uttar Pradesh and Madhya Pradesh, the Bundelkhand region, then Marathwada region, Maharashtra, then Bellary region of Karnataka, adjoining area of Telangana and Andhra part, few area of Tamil Nadu state. So various parts of country which are already are significantly affected and impacted because of the recurring phenomena of drought in particular area specific. So this is all about the background part. Now in next come to the part of definition. Normally people are talking about the drought as unavailability of rainfall or unavailability of moisture conditions defined as a drought. Although it is correct, But if we talking about specifically this scientific understanding or scientific definition about drought, so as it is mentioned here, which is already declared in Glossary of Meteorology in 1959, and where they define the definition, where the word, that definition, each and every word has a specific mean. Like as I mentioned here, a period of abnormal dry weather sufficiently prolonged for the lack of water to cause serious hydrological imbalance in affected area. So if I'm saying a period of abnormal dry weather, so if I'm saying a area specific, like for example, parts of Rajasthan, parts of Bundelkhand region, parts of Marathwada region, Bellary region, where the area is already classified as semi-arid to arid because of its climatic conditions. So it's a like journal or normal status of the particular area. So if the abnormality we have to define, then we have to take a long-term mean or long-term average of rainfall or weather parameters for the particular area, and on the basis of the rainfall availability on in the particular season with compared to long-term mean, then we can say it's a dry weather or wet weather conditions in the particular period of time. Then sufficiently prolonged for the lack of water. Sufficiently prolonged, it means we have to define in terms of a significant period as a dry spell for the particular region or particular location, so that we can define it's a, yes, this is a condition of drought, maybe meteorological, maybe hydrological, or maybe agricultural drought, but based on the a significant period we can define, yeah, there is a drought condition. Then lack of water to cause serious hydrological imbalance. As you have a idea about the hydrological cycle, like the water circulation from earth to in formation of cloud, then rain, and from land to ocean movement, so all this stuff, all this water cycle comes under hydrological cycle. And each and every para component, or you can say the integral part of this cycle, if any phenomena or any parameter may affect, which may cause impact on hydrological cycle. Like for example, if unavailability of rainfall may prolong for a season or for a significant period, for you can say fortnight or for a month, that cause a serious hydrological imbalance, maybe because of unavailability of water at the surface and as well as the subsurface area, and the hydrological imbalance in the affected area. So always we have to define the drought as a local to regional scale based on the information of the affected area only. So this is the specific scientific definition which give a clear and crisp information about drought. Now come to the part of drought, the silent threat in Indian rural economy. As you have already idea with respect to our total population, like we are already cross 140 crores in terms of population, and out of our entire population, around 55 to 60% population are solely dependent on agriculture and agriculture allied activity. And while if I'm saying that around 60% population dependent on agriculture, so because of the drought situation, the immediate victim of drought is only agriculture and the person who depended on agriculture and the related entrepreneurship. Along with this, if I'm talking about the consequence of the crop failure or consequence on the agriculture, there may be also increase the condition of the cattle starvation because of the unavailability of the fodder as well as the drinking water with the particular area specific. And same time, it also cause unemployment conditions for the rural population and which are solely dependent on agriculture activities. Like might be farmers may work in his or her farm. Along with this, he or she may take care about its adjoining field on maybe lease basis or maybe you can say the contract basis. So if such drought condition may prevail over the region in the particular time or season, so that may also lead up the situation of unemployment because of the drought condition. If I'm talking about other non-agricultural impact, the very first or important impact is the drinking water shortage. And if the drinking water shortage is not only for the human population but also other remaining animals or organisms, so that like if I'm saying the livestock or the cattle which are lying on the particular area as well as the wildlife which is also affected because of the drought situation or unavailability of rainfall, that may lead up the situation of the surface or subsurface decrease in the water level. If I'm talking about the frequency of the drought, as it is mentioned in the same slide, the frequency of drought from 1871 to 1999, the western part of the country, specifically the western Rajasthan region, then the Kutch region has the highest frequency in terms of occurrence of drought or recurrence of drought situation. And with follow-up, the area of eastern part of Rajasthan, eastern part of Gujarat, region of Marathwada, Bellary, parts of the Telangana region also significantly affected because of the moderate to severe condition of drought in the particular area specific. So this is overall about the things related to drought. Then come to the part of next topic is related major causes of the drought. The first and foremost important cause of the drought is erratic behavior of monsoon. As you already seen the current situation in our country, like already IMD declared, the India Meteorology Department declared this is a El Nino year. Along with this, the WD, the Western Disturbance, integrate a catastrophic incidents in various parts of country, especially in northern India, like parts of Himachal Pradesh, Punjab, Uttarakhand, and the adjoining states and area. So if I'm saying the erratic behavior of monsoon has ultimately impact on drought, so and like same time our main population, like out of total population dependent, out of total 60% population dependent on agriculture, and their agriculture also mainly for the monsoon season or kharif season. And if the monsoon or rainfall availability may affected, unavailability of rainfall or maybe erratic behavior of rainfall availability in any area, it may significantly impact on agriculture production or crop growth. And ocean atmospheric circulation and disturbance also with the same time, if we talking about specifically ANSO, as it is mentioned in the slide, the El Nino Southern Oscillation Index, which is the integration of the pressure, global pressure difference in the region of Pacific region and Indian Ocean region, and because of the global wind circulation and the pressure difference, if the things like El Nino conditions may happen, it means the pressure is higher because of the high pressure is higher because of the in any areas in the comparison of the Pacific region and Indian Ocean region. If I'm saying the Pacific region has high temperature, and because of the high temperature it's become low pressure zone, and subsequently the area of Indian Ocean in the equator region become the high pressure region. And as the basic law of principle and movement of air or movement of winds due to the pressure gradient from the Indian Ocean to Pacific Ocean, the winds move, and as the winds move, carry the water content also. So that's condition emerge or defined as a El Nino situation, which is all as IMD already declared this year. And because of that, the erratic behavior of rainfall pattern may happen in different parts of the country. Also, the rapid depletion in the forest cover, soil moisture level, which is also cause of the drought for the particular area specific, and which may also affect the rainfall availability. Then timing of water supply or irrigation frequency, as various parts of the country where people are doing agriculture, might be they have one time or a two-time irrigation facility at their farm. At the time of initial stage of the crop growing in the kharif season, and if the dryness of the condition or dryness period or dryness condition may prolong for a period of, you can say, up to 15 to 20 days or up to the 1 month, so farmers forcefully, like they have to apply the irrigation at, although they have only one time irrigation facility, like we say quantity of water, but they have to save their crop with this irrigation. And if the same kind of dryness condition, unavailability of rainfall may happen at the mid of the season or end of the season, that may be also create a significant impact on crop condition as well as the final crop yield. So that is also major cause of the drought. Then excessive use of the surface and groundwater at the time of initiation stage or middle stage of the crop growing condition. If the water is extensively used at the time of the harvesting or at the time of the maturity, if the farmers may not have the water at their farm, so there may be also decrease the qualitative attributes of their final yield or the crop. So these all are the major causes of the drought. Then the impact of drought. There's a number of impacts, but few of I already enlisted here. Like very first is the shortage of the food production due to the failure of the crops because of the unavailability of the water or the rainfall in the particular area. Then shortage of the drinking water and the fodder of the livestock, same time, which may ultimately lead up the situation of the impact on animal population, as well as the rearing in the particular area specific. That's why they are moving from one region to another region, which may also lead up the situations of the tussle between the various population and communities or the tribes in the area specific. Along with this, the deforestation due to the unavailability of the fuel and the agriculture waste because of the unavailability of the fodder and the other resources. Then come to the next, which is the type of drought. As it is mentioned in the slide, in many of the literature, they already define these three type of drought, like meteorological drought, hydrological drought, and agricultural drought. But with the advancement of the you can say theme specific of drought, currently like researcher or scientists, they are talking there are total 5 type of drought as it is mentioned in the slide. Like very first, if I'm talking meteorological drought, when the actual rainfall is significantly less than of 25% over the particular wider area based on the long term average of particular area. Then hydrological drought, a marked depletion in the surface as well as the subsurface water, which may lead up the situation of drying up your area of you can lake, reservoir, rivers, and which may create a hydrological imbalance of the particular area. And third and most important, which is agriculture drought, which is significantly impact on you can say quality number of significant number of population or pan India, where that such kind of drought condition may prevail in particular season. So what is the agriculture drought? So as is defined here, inadequate water availability for the crops due to imbalance between soil moisture and crop evapotranspiration. Like crop, as you already have idea, might be with respect to agriculture domain. Like crop evapotranspiration basically is the water loss condition or by the plant as well as the soil, or you can say it's a combination of evaporation as well as the transpiration. So with a normal crop growth or crop condition, the plants normally or crops doing the evapotranspiration at its potential stage. But with this availability of the constraint is the moisture condition or constant as a soil moisture. If soil moisture is adequate, plant growth is in normal states, the status is normal in terms of its growth and development. But at the time when the soil moisture is depleted over the time because of the unavailability of rainfall or unavailability of the irrigation facility, there may ultimately impact the crop transpiration. And if the crop transpiration process may impact, so which ultimately it's you can say result we can easily depict through the final crop growth and yield part. So the due to the imbalance between the between soil moisture and crop evapotranspiration define the agriculture drought situation in the particular area or location. Then this ecological drought, which is also very much important because it's refer the ecological damage caused by the lack of soil moisture. A area of reservoir, natural reservoir, or maybe the you can say the sanctuary park area or where wildlife exists. So because of the unavailability of the rain or unavailability of soil moisture, various organisms which are lying on surface or near to the water body, they are also significantly affected because of unavailability of water. And there that condition may lead up the situation of ecological imbalance. Ecologically, it means like one kind of organism may higher in terms of population, other may lower in terms of unavailability of the condition of particular moisture or water. So this is defined as a ecological drought. Then fifth and final one, which is defined the socio-economic drought, when the demand of any economic goods exceed by supplies because of the shortage of weather related shortfall of the rainfall or the water supply. So that is ultimately impact on social status of the farmers or the population as well as the economic. So it might, if I'm saying if the rain unavailability of rain may impact the economic status of the farmers, same time it's also impact crucially on the social status of the farmers or the population for the area specific. Then there another type of classification which is based on the time of occurrence, and here as it is defined in this slide as early season drought, mid season drought, late season or terminal drought, apparent drought, and permanent drought. Early season drought, when initial stage of the particular season, specifically like if I'm saying the southwest monsoon period, the June and July month, when initial part of the season if rain may not happen or rain may not available in the any region or area or location, so that may cause the situation of early season drought. And because of this early season drought, there may be a chance of the, you can say, mortality of the crop, as well as there may be chances of complete crop failure if the dryness may prevail over the period of like fortnight or up to the 1 month. Then mid-season drought. The mid-season also significantly impact on the crop growth and final yield. Like at the time of the peak vegetative stage or the transformation from the reproductive stage, vegetative stage to reproductive stage, if the same time if water is not available, so the plants or the crop ultimately or forcefully they are their reproductive stage are not adequately transformed, so because of that, there may be a loss in terms of crop yield, which is defined under the mid-season drought. Then late season or terminal drought at the time of the final maturity or senescence, if the rain is not available, where you can say the grain or the final produce of the crop and plants attain its proper size. So it means the particular late season or terminal drought significantly impact on the tone, texture, color, or basically we can say qualitative attributes of the final yield. Then apparent drought, which is defined as like any area which is suitable for the sugarcane cultivation or the rice cultivation, but because of the unavailability of rainfall, farmers or the area specific population forcefully have to cultivate another crop like maize or sorghum because of the unavailability of water in the particular area or unavailability of the rainfall in the particular area. That is also type of drought which is known as a apparent drought. Then permanent drought, where the area already classified as arid or semi-arid condition and their annual rainfall less than 50 mm and on annual scale, so their total length of growing period is less than 50 days or 40 to 50 days. So if the moisture condition may prevail from the last you can say previous month, or if the condition may happen with this succeeding season also, that also give a boost. If the moisture is available, then only a short duration crop may cultivate in the particular area, otherwise that particular area is not suitable for the crop cultivation at all. Now come to the part of conventional approach. The IMD, the India Meteorological Department, they define the meteorological drought. And as meteorological drought definition, what is the meteorological drought? As we already discussed, like an area which is less than 75% of its long-term average value. So IMD define based on the rainfall ability for the particular area, is the area classified as a mild drought, moderate drought, or severe drought. As we define the classification, like less than 75% of long-term average value is defined a mild drought, 26 to 50% then it's a moderate drought, and if the deficiency condition or deficit of rainfall may exceed by 50%, then it's defined a severe drought condition. But how we define the drought condition for pan India for our entire the country scale? So it is also defined in the same slide and in the drought manual published by Ministry of Earth Sciences with concern of IMD, India Meteorological Department. As they mentioned, when the rainfall deficiency exceed by 10% and same time exceed by 20 to 40% of total area of the plains in the country. If the condition may prevail with the same, like 10% of rainfall deficiency exceed or 20 to 40% of total area exceed on the plain, then country scale is defined is a drought for pan India level. Now, how IMD declare or monitor the drought condition, specifically the meteorological drought condition? So for that, they are calculating and defining the AI. Basically, it's defined based on aridity anomaly index, and which is the derived or computed through the observations of potential evapotranspiration, calculation of the potential evapotranspiration, as well as the actual evapotranspiration. The potential evapotranspiration is calculated using the Panman formula, which is based on the meteorological parameters, and actual evapotranspiration is calculated based on water balance technique, and based on the potential evapotranspiration and actual evapotranspiration, they define the aridity anomaly index. And as the aridity anomaly index value is less than 0 or 0 near to the 0, it's defined a normal condition or non-arid situation. But if the values on the positive sides, it's indicated as or experience for the particular area as a more arid to the drought condition as compared to the normal. So what are the scale? What are the range? As is defined in the slide, the anomaly of aridity index as a classify if the value of AAI aridity anomaly index is 1 to 25 is defined as a mild arid, 26 to 50 the moderate arid, and more than 50 defined as a severe arid condition. This is all about the meteorological drought. Along with this, one of predominant kind of type of index which is named as standardized precipitation index, SPI, which is also used for monitoring of meteorological drought. Not only you can say region specific, but globally this is most used meteorological index to define the calculation of meteorological drought any area specific. So for that only they are using the rainfall data sets, long-term rainfall data sets, as well as the particular season specific rainfall data set. The formula as it's mentioned in the slide, SPI is xi minus x bar divided by sigma, where xi is defined for the particular season specific or the period specific. Normally people are doing this particular SPI computation for the monthly scale. So the SPI, so xi for the month specific period of rainfall with comparison of x bar, which is the mean rainfall, long-term mean rainfall for the particular area specific, maybe the sub-district scale, district scale, or the state scale. Then sigma define the standard deviation with the same corresponding period. So based on the SPI value, there is also categorization of the drought, as it's mentioned the category from denoted from D0 to D5. As through the description we can easily define if the value is minus 0.5 and above, there is a normal condition or no drought condition as defined is description. But as the SPI value decreases in the negative side, so more dryness may prevail for the particular area, as well as the drought condition may become severe to see extreme or exceptionally severe drought condition with more negative SPI value, as it is mentioned in the table of the slide. Now come to the part of drawback of conventional approach. Although they are using significant quality information about the ground observation data sets, but they are partially distributed weather net from the sparsely distributed weather network, as well as for the point scale observation, and sometime where the location has very sparse or you can say scattered distributed weather network. So using that information, if we define the meteorological drought, which is not give the significant information for the particular area or location. So in the same context, the solution no doubt or undoubtedly rely on with a combination of monitoring tools as well as the ground information. So here we can use remote sensing as well as the weather information together as an integrated approach for producing regional to national level drought maps or dryness condition for the area or location. So how remote sensing or geospatial technology can be used to define the drought or specifically the agriculture drought. I think my earlier speaker already discussed about the NDVI or band specific variation with respect to wavelength. So I just give you a glimpse with this particular slide, like how with the variation in the wavelength basis in specifically near infrared red as well as the red band variation in reflectance, and using this information we qualitatively define the condition of vegetation. Like if the NDI as the compare of NIR and R band near infrared band and red band reflectance, we can define the stress condition and healthy vegetation condition with their reflectance value. And the same information is already depicted in the same figure as it is mentioned. Like stress vegetation in red band, their reflectance on higher side, but in the NIR band the reflectance is on lower side. Vice versa in compare of you can say NIR band, the healthy vegetation has low in terms of red band, low reflectance in the red band, and high reflectance in the NIR band. So with the information of NIR band and R band subsequently, we can derive various kind of index. Specifically, like mostly if I'm saying the most used spectral index spectral vegetation index is NDVI, normalized difference vegetation index, which significantly used for assessment of the crop vigor and also denote as proxy of crop vigor. So remote sensing based drought assessment and monitoring, where we can use various spectral vegetation index which may be generated using NIR band, R band, and maybe other band like green band and blue band, and using that we can define the various spectral vegetation index, and these spectral vegetation index are ultimately used to define, maybe solely or with a integrated approach, to define the what is the status of the crop as well as the crop monitoring condition. So in the same, like a very first, as I define a VCI, which is also known as the scaled NDVI, as the formula is given in this slide, NDVI minus NDVI minimum divided max minus NDVI minimum multiply with 100. So as we multiply with 100, it means we are simply scale up data set from 0 to 100. While we are talking about the maximum and minimum, that is the long term maximum and minimum for the particular period specific, while NDVI is defined for particular same month or the period specific NDVI image or the value. So with respect to VCI value, if the value of VCI is higher than 50, it's a condition of normal. But if the VCI values decrease as much as decrease, it's defined more severity in terms of drought conditions, as is defined in the table also. Like the value of 35 to 50 is defined the moderate drought, while the values vary from 0 to 35 define the severe drought condition. So with contemporary of that, as I also put one case study, like we did one study for Marathwada region, where we compute VCI vegetation condition index using MODIS 16-day NDVI datasets. So as you can see in 2001, 2002, all the 12 years, so that is the 15-day, basically it's you can say the 16-day composite of MODIS datasets of NDVI, and based on the NDVI datasets we compute VCI, and the 16-day basis VCI is represent in the same slide. So with this same information, like what kind of information we can infer from this particular slide or such kind of study, when we use like maybe fortnight basis or weekly basis or maybe monthly basis of data set. So with a comparison of normal season or normal year to the drought year, we can significantly define what are the variation in terms of a normal year with respect to drought year, as well as the within the drought year, what kind of the drought type was there. How we can define, like if the lower the VCI value or lower VCI scale is predominant in the month of like starting of the period, starting of the season, so we can say it's a early season drought. If it is in mid, it is a mid season drought. If it is a late, it is a late season or terminal drought. Like in the case of 2002, in the same slide, you can easily infer there was a stress condition in initial phase, but at the same time also at the time of the end of the season, and which is much more significantly defined from the particular results of 2002 last imagery. And with this information as well as the national level statistics, you already have, all the participants already have a significant idea. Like 2002 was the one of the most significant or most worst drought in last 1 century, and the result is also illustrated in the same figure from the 2002. You can say with this also. Likewise, in this study we use MODIS 16-day composite of NDVI datasets for Marathwada region, and we define very precisely like 2001, 2004, 2008, 2013 were severely drought affected year, while 2005, 6, 7, 12 and 14 was the moderate drought affected year. Now come to the next, the National Agriculture Drought Assessment and Monitoring System, which was a, you can say, earlier it was developed by NRC or ISRO. Basically it was the brainchild of ISRO, and which provide that very near real-time information of prevalence, severity level of and the persistence of the agriculture drought at the state, district and the sub-district level. As of currently, 17 states of India is covered under the particular projects as well as the results part. Now the technology part, all the technology and the information transferred to MNCFC, Mahana Lobis National Crop Forecasting Center, which is situated in Pusa campus, New Delhi. And they are carried out the assessment of the rainfall, remote sensing based spectral vegetation index, moisture adequacy index for Kharif season as well as the Rabi season. So in this, they are using or they are follow up the new drought management manual published in 2016, and with the amendment in 2019 they are also doing the drought assessment for Rabi season also. Earlier it was only defined for the Kharif season, but with amendment 2019 and the drought assessment or monitoring part are currently doing with Kharif season as well as the Rabi season. Now come to the part of this flow chart as it is depicted in the slide, the drought assessment of the pan India level. So they basically compute the impact indicator or mandatory indicator. So based on the first mandatory indicator, then impact indicator and ground informations, with step by step they are doing the assessment and finally assess how much area and which parts from our country is classified as a severe to drought in a particular season. How they are using. So very first on continuous basis, a very real time applications they are doing with a mandatory indicator drought mandatory indicators computation. So for that they are specifically use the rainfall data sets, and using the rainfall data sets they are computing the rainfall deviation, dry precipitation index as well as the dry spell period, or you can say unavailability of the rainfall period. So based on their information of the rainfall derived parameters, a matrix is generated as it is illustrated in this slide. So the rainfall deviation of the dry spell, which is as categorized is trigger 1 condition, and if the trigger 1 condition is set off, then they are going for the second step, which is defined as the impact indicator computation. So very first, if I'm talking about the trigger 1 condition where the deficiency or scarcity of the rainfall data sets as well as the SPI value is less than -1, which is defined moderate to severe scale of the drought conditions, with a same time the availability of the dry spell for the particular area specific. If the condition, both the conditions are prevail for the particular area, yes, the drought trigger conditions defined as yes, and if the drought condition is set off, then they compute the impact indicator. And in particular impact indicators, they are using 4 different kind of impact indicators. One is agriculture, then remote sensing, soil moisture and hydrology. So one by one they are doing all the assessment in terms of each and every parameters. Like in agriculture they are doing the computation of how much area is already sown. So the crop acreage estimation they are doing with ground information as well as the remote sensing data set. Along the remote sensing data sets, they are computing VCI as well as the NDVI deviation. Using soil moisture data sets, they are computing percentage available soil moisture as well as the moisture adequacy index. And in the hydrology component, they are computing the stream flow index, the reservoir storage index, the surface and groundwater index, and other many more. So number of index they are computing, and based on out of 4 type of impact indicators, if 3 are categorized and define the severe to moderate kind of condition of drought, then ultimately decision is based on the judgment of ground survey. So the intensity of drought from the impact indicator as it is mentioned in the slide, like severity drought or severe drought and moderate drought or normal conditions. So if I'm define the severe drought condition or severity in terms of specifically drought class. So if all the selected 3 type of impact indicators are in the severe category, is out of 3, 2 are in the severe category or moderate category, then it's classified as a moderate drought, and other remaining conditions are defined as a normal or thing. So if the trigger 2 will set off with respect to the finding of severe and the moderate drought, then the step 3 come into the picture, and which is completely based on the ground information as it is mentioned here also. Like the final determination of a drought is based on the sample survey for the ground truthing. So with the ground truthing or the sample survey for area to area, village by village, they define, yeah, this area, this village is severely affected, this village is moderately affected, and how much area under the particular natural calamity called as drought condition with this season. Then come to the part of few case study. We have to define like how we use significantly remote sensing data sets for assessment of drought in terms of duration as well as the frequency part, and how as well as the what are the best parameters, best indicators which define the drought condition significantly for the area specific, as well as how we can use remote sensing for the same kind of study. So in the same, I just showing here a few case studies in the same series. So very first case study is related to estimation of duration of agriculture drought, which is very much important. Why it is important? Because if I'm saying the duration, if we know a quality manner how much duration of drought or how much duration of the dryness in the particular area, we can easily assess the impact of drought in terms of crop production and crop condition. So for such kind of study or such kind of things, we can use remote sensing data sets. And here, as we use VCI maps, as I earlier show in my previous slide in the same lecture, like we use the same binary VCI maps and we convert into the binary. So binary, it means we convert the data sets in 0 and 1. So how we classify the 0 to 1? If my VCI value is less than 50, we make it 1. And if my VCI value is higher than 50, we make it 0. It means where is 0, there is no drought condition or normal condition. If the value is 1, it's defined as drought condition. Then using here the formula 16 multiply summation I1 to n and small di. Why we multiply here 16? Because here we are using mod is 16-day composite. That's why here we multiply with 16. So it which represent the day basis in the duration part. And summation I1 to n, as in previous slide, as I show, there was total 6 image in per season per year. So that my small n is 6 and small di is the VCI maps binary form. So with the integration of these all 6 binary VCI maps with multiplication of 16, so year wise I can define the duration of drought. So this is as we did this study for Marathwada region. So we can define that drought duration for the period of 0 to more than 80 days, or around we can say 96 days for the totality in terms of duration part. Now come to the part of estimation of frequency of agriculture drought. So which is also significantly important, because if we know what are the frequency of drought in terms of recurrence of drought for the particular area specific, the same area specific farmers, population, as well as the government, state government as well as central government put their specific impact on or specific attachment with this particular area in terms of apply new policy, new scheme for the particular area, so that farmers, their livelihood may sustain and farmers may least affected or impacted because of the drought condition or recurrence of drought situation. So it is also important. So if we define what are if the frequency is higher in any area specific, like from the results of this figure, you can easily depict, like in Marathwada region, western part has higher frequency, like which is the part of the if I'm saying the Marathwada region, the district name, the Aurangabad, the Beed, the Usmanabad, these district has Latur, these all district has higher frequency of drought. So in the same, we are also using the VCI binary maps as using this particular formula, the summation I1 to 15, because here we are using 15 year of data sets from 2001 to 2015 of mod is 16-day composite, and in per season they are 6 image, so I summation 1 to 6. So with this formula we compute the drought frequency and assess which area has higher frequency of drought. Then the next case study, which is specifically for meteorological drought with computation of SPI, standardized precipitation index, at block level of Marathwada. There are around 76 blocks of Marathwada region. So we use remote sensing derived data sets of rainfall, and we did this study at the block level to define what are the SPI variability in the particular area with year by year. So with a representation of results, as we define the drought year, moderate drought year, or normal year, like 2002 and 2015. which was the severe drought year or the drought year where all the blocks has subsequently negative SPI value, which is higher than or close to 1, -1. While in moderate drought year, some of the blocks has positive value, some of the blocks has negative value, which declare like some of the area has affected, some of the area are normal status in terms of meteorological drought. Then in normal year, where all the SPA value are on positive in 2007 and 2010. Then one more case study related to the integration and combination of the agriculture drought assessment, which is also very much important because currently people are researcher are already did number of studies in this particular domain, and they have a quality idea about the particular theme, that a single index may not give you a quality information, a precise information about the crop condition or maybe the crop growth. Like if I'm saying the crop growth is mainly dependent on moisture availability, the local weather condition, as well as the rainfall, like if I'm saying in broadly sense. So if we integrate different kind of products, and with the integration of all the products, and we generate a integrated drought index or combined drought index, which may give you a more significant idea about the drought assessment part. So under the same thing, along with this, like people are mainly working with the Kharif season drought condition. But here in this study, we did for the Rabi season drought of Bundelkhand, Uttar Pradesh region, where we are using around 20 years of data sets for all the data set from the remote sensing products, and we did this analysis. What are the analysis we did? The methodology flowchart is mentioned here. Here we specifically integrated the data sets of result from MODIS and DVI, the normalized difference vegetation index, the land surface temperature, rainfall data sets, soil moisture data sets, and these all data sets basis we integrated vegetation condition index, temperature condition index, precipitation condition index, soil moisture condition index respectively. And along with this, with all integration of data sets, we integrate these data sets based on MCDM approach, which is multi-criteria decision making. Basically, we weighted using the AHP process or analytical healthcare process, we define the weightage for the particular parameter which significantly impact on the crop yield part. And with this result, we also make a comparison with crop yield anomaly using last 20 year of data sets in Rabi season predominant crops in the particular area Bundelkhand, Uttar Pradesh. So as the results are depicted in the slide, like analytical hierarchical process AHP based combined drought index with a comparison of the drought year on upper side and normal year on lower side with the integration of all the data sets. But along with this, when we compare or we correlate with Rabi season, specifically like as we identify the area of the study, which is Bundelkhand UP, which is predominant in terms of crop type like gram, field pea and beans crop. So we compare their crop yield anomalies also with respect to all the year, all the period of study. As we are using, I think we availability of the data sets are around 18 year of data sets. The data sets are also available on our Ministry of Agriculture and Farmers Welfare websites. So the data sets are free in terms of the crop area production productivity data sets. These data sets we are using with a comparison of our AHP derived combined drought index. And with this result, we achieved a very precise result or a quality result in terms of like district level correlation between the crop yield anomaly as well as the AHP derived the mean of combined drought index of the Bundelkhand region for all 7 districts of a particular region. The correlation was more than 0.7 for all the 7 districts. Along with this, as we compare the normal year with respect to drought year, the yield anomaly also defined very precisely, like in normal year crop yield anomalies are on the positive side, when the drought year the anomalies are on negative side. Then a next case study which is related to the agriculture drought vulnerability assessment. So the drought assessment and monitoring is important, as well as the vulnerability currently people are or researchers are doing in the area for understanding how much this, you can say, the particular phenomena make the system more vulnerable and how we assess this particular kind of vulnerability. So in the same regard, we did a study for the Marathwada region at the block level of entire Marathwada, the all 7 district of Marathwada region, uh, 8 district of Marathwada region, which is specifically computation with ADVI. And here we compute the agricultural drought vulnerability index, which is a integration of sensitivity index, exposure index, and adaptive capacity index. In the same study, the ADVI is ultimately integrated with SI, EI, or AI. So SI, what are the sensitivity index parameters in this study? As here we are using more than 15 year of data sets of NDVI, and based on the particular NDVI data sets, we compute coefficient of variation of integrated NDVI and range of integrated NDVI, the duration, frequency, and elevation. So these all data sets, based on their weightage, we integrate, we normalize the data sets, we integrate the data set based on their weightage and generate the sensitivity index. With same in exposure index, we integrated the SPI, which is based on the rainfall data sets and the population density. And very much important in this study, which I want to emphasize, like here as we compute the adaptive capacity index, which are mainly derived from socio-economic data sets, as it is enlisted here, like percent of agricultural labor to the total worker, literacy rate, percentage decadal variation from 2001 to 2011 based on the census data sets, then percentage change in the small and the marginal land holding area, then percentage irrigated area to total cultivatable area, and standardized water level index. Basically here we integrate all the socioeconomic parameters with a comparison also in terms of 2001 census data sets and 2011. Like for example, if I'm saying the percentage of agricultural labor to the total worker, so how much of population or how much of number of labors which are associated with respect of agriculture or agriculture allied activity out of total number of workers. If the agricultural labors are remain constant with the period of study or with the period of time with respect to block level of entire Marathwada region or entire study period or study area, so we can say it's a condition like agricultural labor are doing their same occupation. It means agriculture is sustained. The vulnerability is less in the particular area. Like same, if the literacy rate is higher, it means people understand the importance of agriculture, the importance of the crop production, and they are making the system viable as well as continuous with respect to area wise or land holding wise. Then percentage decadal variation in terms of population as well as the number of male and female, along with this and the labor number, or sorry, the number of the agricultural labor, along with this how much area in terms of percent change in small and marginal land holding. If the land holding is not significantly changes, okay, so which define like the farmers, the area specific field, the block level or maybe the village level specific fields are further, at the time the field was not further fragmented, which give a significant information like the agriculture fields are remain same and their cultivation practices are already ongoing. Then irrigated area as compared to the total cultivable area, then water level index, if it is sustained and they are not marked depletion in terms of water level index, so that make all the system adaptive with the such kind of situation of vulnerability. That's why in this formula ADVI, the SI and EI are integrated, but AI is in negative, so that we decrease the values of adaptive capacity index, which make system more, you can say, inherent as well as strengthen the system against the vulnerability scale. As we did this study for computation of Marathwada region, the final maps figures are here in the slide. The sensitivity index, exposure index, and adaptive capacity index are mentioned here. With this with integration of all three results, as we finalize the final agriculture drought vulnerability index, and from this study, from this result, you may get a idea. Those who are from Maharashtra or Marathwada region, they have, I think, quality idea about which area I want to depict here in terms of very high vulnerable to highly vulnerable. like the parts of Aurangabad district, then Latur, few parts of Usmanabad are highly to very highly vulnerable in terms of vulnerability scale or ADVI. Okay, now come to the part of the various global products or regional products which we directly use, we can directly access, we can directly download the data sets using the particular URL. The URL are already mentioned in each and every slides with respect to the particular products. So in the same series, very first product is the Global Drought Information System, where we can get the data sets related to the drought monitoring part, specifically 1 month SPI, 2 month SPI, 3 month SPI, as well as the VHI, which is integration of VCI and TCI. So this all are the global level product. We can easily visualize the data sets, and also we downloaded the data sets in .NET file on format. We can easily use in various GIS software and platform, and we can interpret as respect to our area specific. In the same, the next product is the related to DMS, the drought monitoring system, which is a product of the South Asia Drought Monitoring System SADAMS project, which was established in 2014, and under the same IWMI, which is International Water Management Institute, situated in Colombo, Sri Lanka. And in this particular project, they are doing the drought monitoring assessment specifically for the period of 8-day, monthly, or seasonal basis using the MODIS datasets, compute the NDVI, NDVI anomaly, VCI, and all their datasets are available in their particular web pages. The next product is the from GID maps, basically from University of California, Irvine. And the GID maps are the Global Integrated Drought Monitoring and Prediction System, where they already defined the results as drought indicator of SPI, SSI, or MSDI. Where SPI, as you have idea, like Standardized Precipitation Index, SSI is the Standardized Soil Moisture Index, and MSDI is the Multivariate Standardized Drought Index. So monthly scale the data sets of the global perspective, or you can say the global scale data sets are available, and using that particular data sets we can define the drought monitoring conditions of the global scale. The next product is the SPEI, which is Standardized Precipitation Evaporative Index, and which is a global drought monitor maps are available. Using this particular SPEI URL, we can check it out what are the SPI variability month by month in the various region of not only India but global scale. The data sets are available from 1901. It means the data sets are more than 120 year of data sets are available in terms of SPEI product. So like these all products we can use not only for a national level but also for the regional level studies, just to understanding of various meteorological index or agriculture index related to drought assessment, like meteorological drought index or agricultural drought index for their computation, as well as the assessment of what are the condition, long-term condition of the any parts of the country or the region, to define their variability, as well as to assess what are the conditions as compared to current as well as in previous year. So like these all are the products. So this is all from my side about this particular topic on agricultural drought monitoring and vulnerability assessment. Thank you from my side.